Hi, I'm Noah Rubin.
And I'm Jade Minkoff.
And today we're going to continue to talk about voltage in a circuit, but we're also going to talk about how to convert a larger voltage into a smaller voltage.
Last time we talked about voltage as a means of providing power, like so. But by changing a voltage up and down, we can also communicate information from one circuit to another. This happens all the time in your devices.
How do we turn a large voltage into a smaller voltage? Let's go back to our most basic circuit from last time. We've already seen that as we increase resistance, current is reduced. That's just like putting a kink in a garden hose. But what happens when we add another resistor? That's just like adding another kink. And the airflow slows. Adding a second resistor decreases the current because resistors wired up this way are additive. Two 100 ohm resistors in series are the same as one 200 ohm resistor.
So now we understand that we can limit the circuit's current by adding a resistor. But what happens to the voltage of the circuit? Well, the voltage between the top and the bottom of the circuit really isn't affected by what happens in the middle. But what about the voltage between the two resistors?
In this demonstration, we use air to represent the flow of electrons. The amount of air at the beginning of the tube compared to the amount of air at the end represents voltage, and the amount of air flowing through the tube represents the current.
We want to remember that voltage is a lot like pressure. So to help us visualize the pressure between our two pretend resistors, we have a balloon that will inflate. Let's see what happens.
Let's start with the most basic cases. Let's call the first resistor R1 and the second resistor R2. If we make R2 larger, that makes the resistive force larger, reducing airflow through the tube. But what happens to the pressure between the valves? Let's see. If you thought the balloon would get larger, you were right. That's because when we make R2 bigger, we restricted airflow here, increasing the pressure between the valves. That's exactly what happens in an electrical circuit. As R2 gets bigger, electron flow is reduced.
But what happens if we make R2 smaller? The balloon gets smaller because the pressure goes down. That's exactly what we see in an electrical circuit. As R2 gets smaller, electrons flow faster between the bottom of R1 and the end of the circuit. If we make R2 really small, that's like replacing the resistor with a wire, and we see that the balloon deflates entirely.
This type of circuit is called a voltage divider. If we wanted to, we could get the equation of the voltage right here at the middle. We only need Ohm's law and a couple other details to figure it out. But we'll jump right to the solution.
The voltage in between the resistors is always proportional to the circuit's input voltage, V. A divider can't make the voltage larger. This makes sense from a physics perspective because we can't get voltage from nowhere. The input voltage is proportional to R2's percentage of the total resistance. That is, R2 over the sum of R1 and R2.
This, of course, matches our intuition from the air experiments. The output voltage of a divider increases as R2 gets bigger and decreases as R2 gets smaller. Voltage dividers are used all the time.
In our next video, we'll use a voltage divider to build a working sensor. I'm Jade.
And I'm Noah.
And this has been an introduction to voltage divider circuits. For other videos in our Thinkers and Makers series, please visit the link at the bottom of your screen and have fun making stuff.